Okay, so we're going to knock out the last bit here with the notes. So all we have left to do is this idea called centrifugal force. So centrifugal force is a word you may have heard before. It's a word that describes this outward push on objects. So what does centrifugal force describes? It describes the outward push on objects moving in a circle. And a good example of this is a merry-go-round. So if you've ever been on a merry-go-round before, so this is a top-down view. You got the merry-go-round, you got like the little railing edges that are kind of spaced around it. Okay? And you sit down on the merry-go-round, and then someone spins it and rotates it around. And if you've been on a merry-go-round before, you know that rule number one of a merry-go-round is spin it as fast as you can so the other person flies off. Okay? There is no other game to play on the merry-go-round other than try to make the other person fall off the merry-go-round to the ground. It's why they're so much fun. It's why they don't put them in playgrounds anymore. You can't have. I found one at a playground, and it was so heavy that you could not spin it fast. Like, it was weighted down. I mean, it must have been 1,000 pounds. It was ridiculous how heavy it was, and you could just barely spin it around. Mario, if you might grab a seat at one of the empty tables. We're just kind of spreading people out as much as we can. So the idea is you spin, you spin, you spin, you spin, you spin, you spin, you spin. At some point, you feel this push you off, and that's why you fly off the merry-go-round. That's called centrifugal force by many people. Now, there's a reason everything's in air quotes. We'll get there in a second. Okay? C, centrifugal force is not real. I hate to burst your bubble. It's not a real thing. In fact, not only is it not real, it's literally called an imaginary force. It's literally what it is. It's an imaginary force. It's a force that feels like it exists, but doesn't. And if you're like, well, if it feels like it exists, why doesn't it exist? The definition of a force we said last unit, so last semester, is that it has to be capable of causing a change in motion. It has to be capable of an acceleration. Centrifugal force cannot accelerate you. It will never accelerate you. And therefore, it cannot be a real force. So why do objects feel like they're getting pulled out from the center? Inertia. I don't know why I started writing a C. So, to stick with my example, it's not that you're getting pulled off, it's that you're going in a straight line, which feels like you're getting pulled off. So, it's not actually going out from the center, it's actually going straight, which from your perspective feels like you're going out. So the reason objects feel like they're getting pulled out from the center is because of inertia. That's why. So there is no force pushing you out. It's inertia trying to go in a straight line. So in what direction will an object travel if it instantly is no longer acted on by a centripetal force? It'll go straight. It'll go in the direction in the tangential velocity. Okay? It'll go straight off, straight off, straight off. I get asked all the time, what would happen to the Earth if the sun disappeared? You'd be surprised that people think about that a lot, but I get asked that question all the time. Okay? There's the sun, here's the Earth. Okay? Earth's going around the sun. Sun disappears because of reasons. The instant the sun disappears, I'm going with the Newtonian explanation of gravity. The instant the sun disappears, the Earth will continue on in a straight line because there will no longer be a centripetal force to make it move in a circle. The reason why it feels like the Earth is getting pulled on, the Earth is trying to go out, is because of gravity from the sun. As soon as you remove the sun and remove its gravity, the Earth will instantly travel in a straight line. And we're not going to worry about E because E is the same question as C. Questions? Woohoo!